This is the Computer Programming University, and this is an update on the web scraping program that I'm working on. Last time we spoke about this, the next sort of enhancements were going to be performance related. The program was running very slowly, and I wanted to look at implementing some caching. So I already started that process, and I want to show you some of what I've done so far, and also show you how the program is currently running. So I'm going to go ahead and run it right now. And just for the record, so what you're looking at right now is this is the HTML data parsed from the web pages. What I've done in an effort to create this caching system is basically get my ugly face off of here. 1 second. Interesting. All right, so I created a temp folder, subdirectory of where the program runs from, and here what I'm doing is I'm creating a bunch of cache files. So this is the HTML data that has been output to files on the actual hard drive. The idea being to reference this data instead of pulling it from the internet all the time. Also, I want to build a background process that keeps these up to date. So before the user even runs the application, the odds are he already has locally the most up-to-date information from these YouTube pages. And this is all around the searching for a string on YouTube pages. So it's a bunch of, the database is a bunch of news YouTube channels, and we're searching those news channels to see if they've posted videos about a particular topic. So each one of these files would represent one of the YouTubers' channels, the HTML file. So if we look at in one of these files, so for example, taxes, Trump taxes came out. That's a big story everyone's talking about. If I do a search for files that have taxes, I can see that 4 of these files have taxes in them, or the string taxes is in there. Now we can use grep-o so we can get a little bit more context. What did I do? Oh, because L, not grep. L and O are not going to go together. So there you have some more information coming out. So what I can do is I can use a regular expression to see a little bit more. So let's see, taxes, and we can do our brackets, and I can do lowercase a to uppercase Z, and include spaces as well. And then let's put a asterisk, and now we get some of the titles are coming up. Leading up to presidency, taxes, the year. So there's probably some special characters that we're missing. So let's just do some more dots to see what else is in there. So it's totally fake news, so that's fine. Presidency. Okay, so we were missing comma. Some of them have commas in there. All right, so let's do that. So we're still missing something else, perhaps some other special characters, but for the most part, you can see these are the titles that are on the YouTube pages that are in the database that I've been scanning. Now, one thing to note is that right now, the last time that I ran this, we see that there's 4 pages that have the word taxes in them. If we look for tax, we see a few more. Now, this was a breaking news story from yesterday evening. So between last night, overnight, and this morning, more people will be picking up the story. So there's probably more hits than this. But currently, the data that I have here is from the 28th at 1:47. So it's a couple hours old. So let's go ahead and run the program and see if we get some new data in there. And just I want to quickly show you what it looks like. So we go to page 34. So this is the HTML data, doc type HTML, and this is what we pull down from the YouTube channels. Now in the future versions, I want to clean this up a little bit more. There's a lot of stuff in here which I can probably do away with, like all this meta tags, but it's kind of complicated the way that they have the information stored in HTML. It's not that easy to sort of parse. So there we get. So I just searched for taxes. So we can see here's a title of a video, right? And if I'm not mistaken, this is part of a very, very long line. So I think like all of this might be the same line. So it's a little bit messy. So I need to understand better about how this is formatted. Maybe I need to use a different parsing tool or something, but it's a little bit messy to deal with. So I see another title here. Joe Biden takes drug test before debate. So that's one video, but again, it's not a very clear sort of format. So anyway, so that's what it looks like. So now let's go ahead and run the program so you can see the latest iteration of this. So we are going to run that.
Enter keywords.
So we're going to type in tax, taxes. What else? Taxes. Tax returns. We get a lot of hits with this. All right, let's go.
Taxes, tax returns. Searching.
Getting a few hits. Identified a bug I need to address as well. My list of sites has duplicates.
I found 27 hits. Opening pages now.
Okay, I'm gonna kill this now because I don't want it to open up a whole bunch of tabs and start slowing down the machine. I haven't addressed that stuff yet. So if you get a lot of hits, it gets kind of messy with the browser bogging things down. What I want to do now is go into the temp folder and take a look at the results of the same greps I did before. So here's taxes. So nothing new came up there. Let's look for tax. Tax. I think there might be a few more. So this is what I got before. 1, 2, 3, 4, 5, 6, 7. And now we have 1, 2, 3, 4, 5, 6, 7. So it looks like we didn't get anything new. Let me make sure these files have been updated. So they have been updated, but apparently no one new posted any videos. Again, this was breaking news from yesterday evening, so I guess it's not entirely surprising. But let's take a look at the code really quick. So if we look at the page loader, we can show you what's happening exactly in terms of the changes that I made to the code. All right, so we scroll on down. Sites match, we initiate our list, sample keywords, stuff is all the same. Searching, site num equals 0. I need to make a note about what site num was created for, because I already forgot why I created that variable. Oh, that's for the naming of the files. So I should put a note there. Variable. to track cache file numbers and or site number. All right, so that's something new that I added. We open the list with all the sites in there, all the URL pages. And so this is how we are creating those files. So we use open, specify the file name. So remember the temp directory we created before. And then we're doing a concatenation. So this is the file that we're creating. I think I might have misspoke. So we're doing a write. You see it says W+. So we're doing a write, right? Open in write mode. And then this is the file name. So temp page as a string. And then we add concatenating, right? We're adding, so page and then what? A string. So we're taking the site num variable, which we are making a string, not an integer, because we're not going to be able to concatenate a string and an integer, right? If we're going to concatenate like this, we need it to be string and string. So this is a string, it's in quotes, right? This would not be a string. So I made it a string by string variable name, right? So that's creating a file called page and the contents of site num. So that means the first file will be page 0. And I did that on purpose to match the index number. Because remember, the sites are in a list, right? The sites, the URLs for each one of these YouTube pages is in a list. Well, this is a list that contains the URLs that contain the string that you're looking for. But the actual list itself is when we open the sites file, which I probably just flew past. Opening of the sites file. There we go, right here. So the with open. So we with open sites.txt, which is the file with all the URLs, as F, right? And then we read each line. So we do f.read lines from sites, right? So we open the file sites as F, and then we read each line and contain the results in a list called sites, right? So now down here, the first item in that list will be index 0. The first file name will be page 0. So I did that intentionally, but I think I'm going to change this for simplicity purposes. Probably unnecessary to do this, but what I'm going to do is, instead of calling it page and then the number, I'm just going to name the files the index number, because I may want to be able to specifically reference the appropriate file for the appropriate index. So for example, the index is a list of URLs. The first URL is in index position 0. If I want to do a search for the specific web YouTube page that is in index position 0, the data will be in a file called 0. Now, of course, I could still call it page 0, but then I would have to extract the number from the name, because the number is what I want. If I want to identify which file has the data for a specific URL, I need to go and grab these numbers. Either I'm going to extract it from page and then number, page 0, page 1, page 2, page 3, or I'll just make the file simply the index number. So therefore, the file name will match the index position of the specific website that it's referring to. So the first URL in our list would occupy position 0. The file, the cache file that would have the data for that particular URL will be called 0. right? So somewhere in there, when I'm writing the code to do that, I'm thinking about keeping it simple like that. So I'll just say file name, index name, right? So have it make sense. So anyway, so this is just the creation of the file. This stuff is the same as before. That's just the opening up of the web pages and then parsing it out. This is something that I was attempting to do, but it's not being used, so we can delete that and close up this gap here. So here is where we do an f.write. So we're creating a file that is called page and then a number. Then we're writing to that file the contents of the HTML that we parsed. So we parsed the HTML page and we contain the results in a variable called soup. Now we're pushing that data into the file, right? Remember when we created this file, we contained it in the variable f, right? So once we parse the HTML and we store the data in a variable called soup, we can now write to f. F is our file that we created. We can now write to it, and we can put the contents of the soup variable, which is the parsed HTML data, right, in a string format. That's why we do string variable name, right? And then we can add a new line at the end of it. So we're concatenating that. So we're taking the data, inserting it into the file, and then we're ending at the next line. So we're not going to end up with the last page data. I mean, that really shouldn't happen, but yeah, I don't think that's necessarily relevant here. But regardless, I just wanted to make sure that I end it cleanly. I don't want to just, you know what I mean? So I just ended a new line at the end of that. So that may or may not make sense. I have to think about that later. But that's it. We create the file based on the index position, and how do we get the index position? We initiate it with 0, right? And how is it incremented? It has to be incremented at some point. So this is a loop. We're for site in sites. So we're iterating through the list of sites, right? So we go through the first URL, second URL, third URL. So somewhere along here, we have to increment this value so we can match up the index position with the file name, right? So if we scroll down, we're doing a 4 words in text. Found site. This is some crap that I need to clean up. I don't think that's being used. That was my attempt to clean up the duplicates, but I think I need to restructure that. But if we scroll down, way down here, we see site num plus equals 1. So zoom out so we can see the full context. So this entire thing is a for loop. So we're doing a for sites in site. So we want to iterate through each of the URL pages. At the end of this loop, the very last thing we do at the end of each iteration is we add 1 to site num. That's what plus equals 1 is going to do. So we're assigning site num a value of we're adding 1 to its current value. So site num equals plus 1. So the second iteration, site num is going to equal 1. Third time, 2, 3, 4, 5, 6, 7. So that's how the file names are being created. And that's how we're matching them with the index position in the list. The only thing is we have to be mindful of is in future versions is this is gonna break if the this depends on the amount of URLs in our list matching the amount of pages that we create. So why would that change in the future? If for some reason we remove a URL from the list, I can't think of a reason why I'd want to do that, but I have to think ahead. If for some reason I want to remove a site from the sites list, then the file numbers are not going to match the index positions anymore. Because now you're going to have, let's say you have 10 files to match 10 elements in a list. You remove one URL, so now you have 9 elements in the list. So now the number of the file no longer matches. So I can't think of a reason why I would do that in the future, but I just have to be mindful that these two things have to go together, otherwise they're not going to match up. So, but that's where I'm at right now. So the main thing that's missing is that I am not yet searching within the local files. This is still a real-time live program. So all of the searching is done in real time, meaning when you type in a string, it goes to the internet, pulls down the data from the HTML page, parses it, and then it does the regular expression searching for the string that you wanted. And then depending on whether it finds a result or not, it's gonna do different things down here. But none of that is cache. So the only thing we're doing locally is we're physically creating these files and updating them every time we run the program. But we never search those files. So all I need to do right now, which I'm excited to see the performance enhancements, but all I need to do right now is I need to create a mechanism where the program is going to search locally instead of from the internet all the time. The other thing is memory, because memory is obviously faster than the hard drive. So it probably makes more sense to start with memory perhaps and then deal with hard drive. The beauty of hard drive is it doesn't go away. So you run the program, you stop the program, the data is still in those files. So when you run the program again, it's still accessible for future searches. The problem with the memory is the memory contents will be removed once you stop the program. So if I store the data for each website in the memory, then when the program stops, the memory gets dumped. So when you start the program again, we'd have to again pull from the internet, store it in memory before it's available for searching. So I'm thinking first time around you store it in memory so it's super fast, and then at some point in time you store it on the hard drive and you use that for future runs of the program, right? So first time around you have to go to the website because you don't have the data, right? So you go to the websites, you store each of the pages, each of the YouTube channel, all the HTML data in a variable, and you're able to quickly search through all of them in that session because it's all in memory, everything's there, super fast. But before you shut down, that stuff should be stored on the hard drive. So then when you shut down the program and you run it again, it does a check and sees that there's files in there. It may make note of, and should make note of, how old those files are, because I want to know if this is from like 2 days ago versus 5 minutes ago, and I want to behave differently. If it's really old, then I'm not really going to trust it. I'm going to prioritize getting updates, right? If it's 5 minutes ago, 10 minutes ago, I'm going to have a lot of faith that we've got some pretty usable data in terms of being able to search what's on people's YouTube pages, right? But start the program, check for the existence of these cache files. You find them, extract the data from the files, throw them in the memory. That should take no time at all. So the second time you start the program, it should very quickly have everything that you need available in the memory. So by the time you finish typing in what you want to search for, it can quickly boom, 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 everything. Search all those pages. I mean, this should be like a second, right? I don't see why it should take more than, I don't know, at most 2 seconds. It's not going to take 2 seconds. I think it's going to take a second to search these files are not even that big. To search the HTML pages for all these YouTube is going to be like 1 second. Boom, here's all your results. Then the only thing that's going to be a delay, the next performance issue is you still have to open up those pages in the browser. But I think the solution there is, I don't think the HTML that I'm saving is usable in terms of the browser being able to open them. I mean, I guess I can do a test. But I'm gonna work on doing like a save as or save all or whatever it is, where you can save an entire web page, not website, but web page locally on your hard drive. And then once I figure that out, I'll be able to open up the pages locally as well. So I can search locally super fast. And then when I need to open them up, I can open it up super fast, because the HTML pages, and I don't know if we could do that from memory as well, in theory. I don't know, but we'll figure that out. Instead of having to go to the internet and access this page and parse it with the browser and then download the images and all that kind of stuff, you're simply opening up a file, the HTML file, locally on the computer. So the main constraint there would be the hard drive, and then also system resources. Every tab you open is going to take up more memory, more potential CPU. So we'll see what kind of latencies we have there. But right now, definitely downloading everything from the internet every single time is bad design, and that's what we're looking to correct. But for today, I just want to get the I want to get the searching to start happening locally. I'm gonna make it local focused, and then I'll implement some kind of logic that makes a decision about, should I check local or should I pull from the internet? How old is the data that I have cached? Is the data there? This is sort of features I can add in the future. But right now, the main thing is I want to make this start searching from the files locally and be able to observe the performance enhancements there, and then start connecting the two. So the live mode versus the offline mode, and reference to the timeliness of the data. So if the files are like days old or hours old versus minutes old, have different behavior. And also, I probably need to start writing some functions. I didn't really do many functions here. The only function I did is for the speech, which I'm not even using. Well, I am using that. What I'm not using is the beeps. The beeps were introducing some latency that I was not liking. I'm trying to make this thing fast. I don't need sound slowing it down. So I think to reintroduce the sounds in a sensible way, I'm going to be forced to take this to the next level in terms of making this a multi-threaded application. I want to be able to basically play the sounds in the background, because the way it works now is, how the code works. You're basically reading the code in sequence. So here we're calling this play sound. We're sending it this argument of this file, right? Then once that's done, we create the sites matched list, an empty list. So the problem here is you're never gonna do this until you're done doing this. So if this takes a second or 2 seconds, then you're introducing a latency of a second or 2 seconds before this list gets created. So it's creating a bottleneck of some sort. So what I would need to do is to play the sound in the background so that the code can continue processing. I want the interpreter to move on to the next line. So you spawn this in a separate thread, and then you move on to the next line of code. So until I can implement that, I'm turning off the sounds, because that's just slowing down the process, because the sounds are in the loops. So every time I find the URL, or the string that I'm looking for, it's making these beeping noises. And until the sound is played, it has to read the file and process it and decode it and blah, blah, blah. Nothing can happen. So it's basically slowing down the search process, which is foolish. Anyway, that is where I'm at. Tell me your thoughts. Any questions you have, let me know. But I'm going to move on to finishing up my code. Well, at least the caching. Finishing up the caching today, so it can read from the files, and then we'll move on from there. This is Computer Programming University, where the first step is to smile, because learning should always be fun, and it is right here on the Computer Programming University. Thank you all for watching. Have a great day. Be safe. And until next time.
Rage on that beat, going crazy.